Hello and welcome to our presentation all about oil, water, surface tension and density. Our names are Ollie, Kieran, Oscar, Jordan and Pete, and we are students studying at Canterbury Christchurch University. During this presentation we will look into the relationship between oil and water, including their properties such as density and surface tension. We believe this is a good topic to investigate as it is linked to multiple United Nations Sustainable Development Goals. For example, oil mixed water sources can cause serious health issues, and this links to the UN's SDG goal number 3, which is good health and well-being, and goal 6, which links to clean water and sanitation. Oil spills can have negative health effects on marine life due to its toxic components. This links directly to the UN SDG goal number 14, which focuses on life below water. We think it's important to link oil and water to these UN SDG goals, as it helps us better understand the negative effects of oil pollution.
Surface tension is a unique property of liquids. It occurs when molecules in the other liquid are attracted to one another. Surface tension allows certain small objects to float on the surface, like the paperclip on the photo. Why does surface tension occur? There are 4 main factors that influence why surface tension occurs. First one is the molecular attraction. Small surface area, high energy at the surface, and elastic behaviour at the surface.
Why does water not mix with oil? This is because water is a polar molecule with a positive charge at one end and a negative at the other end, whereas oil is made up of non-polar molecules. The water molecules attract to each other and exclude the oil. The oil molecules then stick together and form a separate layer on top of the water.
How do oil spills happen? Oil spills can happen for several reasons. Tank accidents occur when an oil tanker crashes into other ships, hit rocks, or sinks. Drilling accidents can happen when an oil rig explodes or leaks oil into the ocean. Pipeline leaks can occur when a pipeline breaks or corrodes, causing oil to spill into the water. Natural disasters like hurricanes and earthquakes can also damage oil rigs and pipelines, causing spillages to occur. Lastly, oil spills can even be released on purpose during conflict to deliberately harm the environment. Each and all of these causes can have serious effects on marine life and the ecosystem around it. Why are oil spills damaging to marine life? Oil spills are very harmful to marine life because of its inherent toxicity to an animal's health. The chemicals in oil can poison sea animals if they are eaten or absorbed, causing health issues that can even lead to death. Oil can also coat birds' feathers and animals' fur, making it hard for them to stay warm and move and fly, which can lead to starvation. It can also block oxygen from getting into the water, so fish and other creatures can suffocate. Oil also blocks sunlight, stopping algae and plants from growing, which are essential for the whole food chain and the ecosystem underwater. The oil can even stain the environment for years if left untreated, harming sea life and even reaching humans through seafood and the water table. There's been some major oil spills across the history. Some of the main ones are the Torrey Canyon spills in 1967, the Exxon Valdez spill in 1989, the Prestige tanker spill in 2002, and the worst of which, the Deepwater Horizon spill in 2010, which continued polluting the ocean for 87 days, causing severe damage to the marine life and local industries. How do we clean up oil spills? Oil spills can be cleaned up in many different ways. Booms and skimmers are tools that help trap and remove oil from the water's surface. Absorbent materials like special sponges soak up oil on a smaller scale. Dispersants are chemicals that break up oil into tiny droplets, making it mix into the water more easily, though this can spread toxins. Sometimes controlled burning is also done, but this releases harmful smoke into the atmosphere. For the shoreline, people often clean up oil by hand to protect the environment. In most operations, usually a mix of all these methods are often carried out. Now we're moving on to the practical. The next slide will show you the video on how you do the next practical step by step. I hope you enjoy.
Fill one beaker with 400 millilitres of water and fill the other one with 40 millilitres of cooking oil. Using a pipette, get your red and green food dye and fill it up to 2 millilitres. Once doing that, put it into the oil, both of them. Following putting the food dye in, use a stirrer and mix together.
The next step is to pour the oil and food colouring mixture into the water. As you can see, the oil does not mix with the water and instead rests on the surface, creating its own layer. If the solution was stirred, the oil would break into smaller droplets and the liquids would look as if they've been mixed. But eventually these oil droplets would regroup and rise back to the surface. The reason why oil sits on the surface of the water is due to density. Oil is less dense than water, causing it to float. As you can see, the food colouring droplets start to sink to the bottom of the beaker, due to it being more dense than the water. This creates a cool effect where we see the food colouring slowly sinking before it causes the body of water to change colour. The next step is to leave the mixture for 5 minutes to allow everything to settle and for the water to change colour. The food colouring represents microplastics and how they too can mix into the ocean differently to oil. It shows that other methods are needed to solve this problem.
For this step, pour the oil and water mixture into the top of the bread and open the valve to allow the water to flow into the beaker below. Now watch closely to close the valve at the right time to keep the oil within the bread. This process works due to the fact that the oil is lighter than the water, therefore the oil naturally rises to the top.
Here is the final product of the water separated from the oil. However, do not drink it as it could still be hazardous. Now it's time for the quiz. Question 1. Why does oil not mix with water? Is it A, because water is heavier than oil, so oil floats on top and they don't blend? B, because oil and water both have the same density, so they push each other away? Or C, because oil and water are too slippery to stay together? Click on whichever you think is the correct answer. Correct. Well done. The answer was A.
What is surface tension? Is it A, how much water weighs when you put it into a cup? B, the reason why water and oil don't mix? Or C, it's the skin on the surface of the water that holds things up like bugs or paper clips?
What do the UN SDGs stand for? Is it A, United Nations Science Development Group, which does research about space? B, United Nations Sustainable Development Goals, which are global goals to help protect people on the planet? Or C, United Nations Security Defence Goals, which are rules for keeping countries safe? And this is the conclusion. We've looked into the differences between oil and water and their surface tension and density. We hope you've learned some things and enjoyed.
If you enjoyed our presentation and would like further reading, we've linked some websites here. Please feel free to use them.